All right, so in this video, we're going to look at mass relationships and chemical equations. Okay, and so from the previous video, we talked about how the coefficients specifically represent your mole values or the amount of moles per each of the substances, right? And so, like we said here, this represents that there are 3 moles of H2. This tells you that there's 1 mole of H2. And then this right here tells you there's 2 moles of NH3. Now, remember, moles is really nothing but a number. It's a number unit. It's a counting unit. So we could say, it just takes 3 moles of H2 to react with 1 moles of N2 for you to make 2 moles of NH3 or ammonia. Which this is appropriate. It tells you, how many of each you need in order to make your products. But in actual chemistry, in the actual lab, molecules are so small, we can't really physically count them out. And so what we'll know is we'll know the mass. All right, we'll know the mass of each of the individual ones, right? And so we'll weigh out the mass of hydrogen, we'll weigh out the mass of nitrogen, and at the end, when you combine them and you make ammonia, you will find the mass as ammonium as well. But what we also know that mass of a particular atom has a lot to do with the atomic weight of each of these atoms. So we cannot use these numbers as they are mass. We cannot, because these numbers don't represent mass, which also, that takes account to atomic weight and how many. This is just telling you how many, okay? And so, for example, if you were told, right? So we'll jump into an example. All right, so if you were told that you were given 25.0 grams of H2, all right, and then it reacts with excess amount of nitrogen N2. And what I mean by excess simply means I have enough N2 to react with all 25 grams of hydrogen. That's all that simply means. That you just have more than enough. Okay, so don't get confused about that term. All that simply means that you don't have to worry about how much or how many nitrogens or the mass of nitrogens. Okay, all we know, we just have enough of it. Okay, and so you have 25 grams of H2 reacts with excess amount of N2. All right, and so then what we want to know is how many grams of NH3 of ammonia will form. All right. So now we want to know how many grams. So what's important is that you realize what units are given to you and what units are you going to, because then this will definitely help us to figure out how to go about each of these questions or each of these problems, okay? And so as I stated before, once you're giving mass, all right, what you need to do is that if you know what's the mass of the substance you have, right, you need to convert this to moles, because the chemical equation only tells you mole to mole ratio, all right? It doesn't tell you mass to mass ratio, all right? It tells you mole to mole ratio. And so if you're given a unit other than moles of a particular substance and you want to try to figure out how much of another substance within that chemical equation, you need to convert whatever it is to moles first. And then, for this class, we'll stick to mass, all right? So we have grams here, and so we need to convert grams to moles. Now, how do we go about doing that? Well, we talked about this. We'll use the molar mass. Why? Because the molar mass is the ratio of grams per 1 mole of that particular substance. All right? And so let's go ahead and go about doing this. And this is a several step process. But let's jump, okay? And so we'll start off with 25.0 grams of H2. Like I said, you start off with grams, you got to convert this to moles first. All right, and so we need to figure out what is the molar mass of H2. Okay, so you'll pull up your periodic table. All right, here's mine. Okay, so I pull up my periodic table and I see that the molar mass of hydrogen, and then we see here that the molar mass of hydrogen is 1.008. Okay, now putting this away. So it's 1.008, which you need to consider that you have two hydrogens here. So it's 1.008 times 2. All right, and so we see that for every 1 mole of H2, it has the mass of 2.016 grams. All right, because remember, it's H2, there's 2 hydrogens. All right, and so I'm going to place this in the proper format of this. And so since I have grams up here, grams of H2 up here, I'm going to have grams of H2 in the bottom, and I'm going to have moles of H2 on top. So 1 mole of H2 over 2.016 grams of H2. Okay, so now this step, all right, and I'm not going to figure out the answer for this one because it's a multi-step process. But this step here gets you from grams of H2 to moles of H2, just like we said we wanted, all right? Because before you could compare and use the equation, what you need to convert it, all right? We need to convert our known to moles of whatever that substance is first, okay? Now, once you've done that, now we could look at the mole-mole ratio of our known to our unknown, okay? And so we're going from H2 to NH3, okay? And so what we're looking at here is the known of H2 to the known of NH3. And we see that the ratio is a 3 to 2. So for every 3 moles of H2 to 2 moles of NH3, okay? And so now we're going to actually put that down here, all right? Looking at where our units are, so my unit from a mole of H2 is up here, so I'm going to write my moles of H2 in the bottom here. I'm going to moles of NH3, so I'm going to write moles of NH3 on the top here, and then I'm going to write the coefficients. And so the coefficient is for every 3 moles of H2, I have 2 moles of NH3. Okay, now following the problem asks how many grams of NH3. Okay, so now that I know how many moles of NH3 I got, now I have to convert this to grams of NH3. Okay, and so what you want to do is you go to the periodic table and you figure out their molar mass of NH3 and N. So nitrogen is here. Nitrogen has the molar mass of 14.007, while hydrogen has the molar mass of 1.008. So I'll put my periodic table out to the side. All right, and so nitrogen, 14.007 grams per mole, while we have hydrogen is 1.008 times 3 grams per mole. And so when we add this up, we'll get our molar mass to be, so the molar mass of is 17.031 grams per mole. Okay, and so I'm going to place that accordingly. So if you notice, my moles of NH3 is on top here, so I'm going to write my moles of NH3 on the bottom. Okay, and then I'm going to place my grams of NH3 on top, and then place the numbers accordingly. So here is your conversion. All right, and so we see that the 17.031 grams of NH3 per 1 mole of NH3. And so let's just make sure everything cancels. So we see moles of H2, moles of H2. So these two cancel out. Moles of NH3 and moles of NH3 cancel out. So the unit I'm left with is grams of NH3, which is exactly what I wanted. Okay, and so now what I put in the calculator is 25.0. All right, divided by 2.016 times 2 divided by 3 times 17.031. And then I hit the equal sign. So when you put all that into the calculator, you get roughly 140.798. All right, grams of NH3. Now, always we have to consider significant figures. And so when we're looking at our original number, we see that original number has 3 sig figs. And so I'm going to change this to 3 sig figs. And so when I change this to 3 sig figs, here's our first 3. This is going to influence the 0 here. And so we're going to have 141 grams of NH3. All right. And so this is the way that you will basically go from a mass, if you know the mass of a reactant or a product, all right, and then converting this to a mass of another substance within the same chemical reaction. As I said, the big key point here is that you must always go to moles first. You go to moles, you convert grams to moles using the molar mass of the substance, and then from there you go do the mole-mole ratio that you could find from the chemical equations. Okay, and then after that, whatever unit they ask you to find the final answer, whether it be you remain in moles or you go to grams, just kind of pay attention to that so that you know what's your next step. All right, so this is it.